Good afternoon, students. So today we discuss about the angle of intersection of two curves. So in the last two classes we have solved problems on angle between the radius vector and the tangent to a curve. So today we find the formula for angle of intersection of two curves. Angle of intersection of two curves. So when the two polar curves intersect each other, then the angle between the two curves is known as angle of intersection of two curves. Right? So here we consider two curves. So here this is the first curve, so which is given by r is equal to f1 of theta. So this is the first curve. And then this is the second curve, r is equal to f2 of theta. So this is the first curve and this is the second curve. Okay, and these two curves are intersecting. At the point P, right? So these two curves are intersecting at the point P. So the angle of intersection of two curves is nothing but angle between their tangents. That's all. So now see here, this is the second curve and this is the first curve and this is the second curve, right? So now this is the tangent to the second curve and this is the tangent to the first curve. Now here the two curves are intersecting, means this angle is nothing but angle between this tangent and angle between this tangent, right? So angle of intersection of two curves is the same as angle between their tangents. That's all. Okay, so now here take two curves, say r is equal to f1 of theta and r is equal to f2 of theta. Okay, so then let phi 1 be the angle between the radius vector and the first and the tangent t1. Okay, similarly let phi 1 be the angle between the radius vector and the tangent to the curve r is equal to f1 of theta. Okay, that is t1. And let phi 2 be the angle between the radius vector and the tangent to the curve r is equal to f2 theta, right? So this is phi 2 and this is phi 1. There are two curves. The one is r is equal to f1 of theta and another one is r is equal to f2 of theta. So phi 1 is the angle between the radius vector and tangent t1 and phi 2 be the angle between the radius vector to second curve and tangent t2. Okay, so now we have to find the angle of intersection of two curves. Now angle of intersection of two curves is nothing but what? This is the angle of intersection of two curves, right? So this is the angle of intersection of two curves. Now this whole is nothing but angle between the radius vector and the tangent t1. So this is phi 1 and then this is phi 2 is angle between the radius vector and the tangent t2. So if we subtract phi 2 from this whole angle, so this is the total phi 1 angle up to from this to this. So this is phi 1. In this phi 1, if I subtract phi 2, only this angle, if I subtract phi 2 from this angle, if I subtract phi 2, then this remains. So this angle is nothing but angle between the tangents, which is nothing but angle of intersection of two curves. Or in other words, we can say that alpha is equal to, so alpha is nothing but the angle of intersection of two curves. Let alpha be the angle of intersection of two curves. So alpha is equal to phi 1 minus phi 2, or take modulus of phi 1 minus phi 2, or in other words take tan to the both sides. You will get tan alpha is equal to tan of phi 1 minus phi 2. So apply tan of a minus b formula and then you will get this equation. So alpha is equal to tan inverse of tan phi 1 is r into d theta by dr, angle between the radius vector and the tangent 1. Tan phi 2 is r into d theta by dr for the curve 2, then 1 plus r d theta by dr, r d theta by dr2. See, this 1 2 implies curve 1 and curve 2. Okay, so this is the formula for the angle of intersection of two curves. So if alpha is the angle of intersection of two curves, then then alpha can be found by alpha is equal to phi 2 minus phi 1. Absolute value of phi 2 minus phi 1. Absolute means angle cannot be negative, so therefore we take absolute value of phi 2 minus phi 1. Now see here case 1. If suppose this is the formula, so alpha is equal to absolute value of phi 1 minus phi 2, this is the formula for angle of intersection of two curves. Angle of intersection of two curves. Now suppose if alpha is equal to 0. If alpha is equal to 0, then what happened? Tan phi 1 is equal to tan phi 2. Tan phi 1 is equal to tan phi 2. This means that the two curves touch each other. This means that the two curves touch each other. This is when alpha is equal to 0. When alpha is equal to 0 means when the two curves touch each other, means there does not create any angle. Okay, if alpha is 0, because alpha is nothing but angle of intersection of two curves. If angle of intersection of two curves is 0, means that the two curves coincide with each other. All along the points, the two curves coincide each other. Okay, so this is the first meaning. Then second is, if alpha is equal to pi by 2, means if angle of intersection of two curves is equal to pi by 2, this means that the two curves cut orthogonally. Means the two curves intersect each other at 90 degree. The two curves intersect at each other at 90 degree. So this is when alpha is pi by 2. And in other words, we can say that if angle between the two curves is 90 degree, or if the two curves cut orthogonally, then tan phi 1 into tan phi 2 is equal to minus 1. Okay, now remember these 2 points, because these 2 points are very, very important when we solve the problems. So in problems they may ask variety of different questions. So like that, either they may ask find the angle between the two curves, or they may ask show that the angle between the two curves is 90 degree. So then you have to show either alpha is equal to 90 degree, or alpha is equal to phi 1 minus phi 2 is equal to 90 degree, or you can also show that tan phi 1 into tan phi 2 is equal to minus 1. If tan phi 1, product of tan phi 1 and tan phi 2 is equal to minus 1, then the two curves cut orthogonally. Okay, so this is angle between the angle of intersection of two curves. Okay, so now we solve problems on this. So find the angle of intersection of two curves. The first curve is r is equal to a, and the second curve is r is equal to 2a cos theta. So these are the two curves, and we have to find the angle of intersection of two curves. So what we do, first we take this first curve, r is equal to a, then apply log. Okay, log r is equal to log a, then differentiate with respect to theta. So 1 by r dr by d theta is equal to 0. Or reverse this, r into d theta by dr is equal to 1 by 0. This is also to be reversed. Okay, then this is 0 by 1, then when we reverse this, 1 by 0, which is infinity. Now this is nothing but tan phi 1. Because why we have taken phi 1? Because there are two curves. So this is for the curve 1. So to denote that, we have to take tan phi 1, which is equal to tan pi by 2, because tan 90 degree is always infinity. Tan 90 degree is always infinity. So therefore we write this infinity as tan pi by 2. So now tan get cancelled. So phi 1 is equal to pi by 2. So this is first angle between the radius vector and the first curve. Next, take the second curve, r is equal to 2a cos theta. Again apply log r. So we will get log 2a plus log cos theta. Then differentiate with respect to theta, we get 1 by r dr by d theta is equal to, this is 0. Then this is 1 by cos theta into minus sin theta. Then reverse this, so r into d theta by dr, and this is also to be reversed. So this becomes minus cos theta by sin theta, so which is minus cot theta. So now this is nothing but tan phi 2, because this is the second curve, we use phi 2. So tan phi 2 is equal to, and this minus cot theta can be written as tan of pi by 2 plus theta. So now tan get cancelled, phi 2 is equal to pi by 2 plus theta. Okay, So now we have to find alpha. So as I already know, alpha is nothing but absolute value of phi 1 minus phi 2. So write phi 1, that is pi by 2, then minus phi 2. So minus pi by 2 minus theta. So cancel each other, you will get minus theta. Absolute value of minus theta is plus theta. So alpha is equal to theta. So this is how we how we find the angle of intersection of two curves. Okay. So next we take another problem. Show that the curves r is equal to a theta and r theta is equal to a intersect orthogonally. Okay, so now say this is r is equal to a theta first curve, and this is r theta is equal to a, or r is equal to a by theta. In any way you can take. Next apply log. So log r is equal to log a plus log a theta. Differentiate with respect to theta, 1 by r dr by d theta, which is 0, and this is 1 by theta. Then simplify, you will get tan pi 1 is equal to theta. In the same way, we differentiate this with respect to theta, and we will get tan pi 2 is equal to minus theta. Now as I already told, either you can show that alpha is equal to 90 degree, or you can show that tan phi 1 into tan pi 2 is equal to minus 1. So now here tan phi 1 into tan phi 2 is equal to theta into minus theta, or which is equal to tan phi 1 into tan phi 2 is equal to minus theta square. So now to show that this is equal to minus 1, now we eliminate from given curves. So now see here, these are the two curves, r is equal to a theta and r theta is equal to a. Now from these two curves we find the value of theta. Okay, so now here what we do, here substitute this value of r in this equation. This r is a theta, right? So here you substitute r is equal to a theta. So you will get a theta square is equal to a. So a get cancelled. Theta square is equal to 1, or theta is equal to plus or minus 1. Theta is equal to, theta square is equal to 1, theta is equal to 1, or plus or minus 1. So that we have to substitute here. We will get tan phi 1 into tan phi 2 is equal to minus 1, and therefore the two curves intersect orthogonally. Okay. In the same way, we show that the curves r is equal to a theta and r into e raised to theta is equal to b intersect orthogonally. Same method you have to follow. The first curve is r is equal to a into e raised to theta. Then let differentiate. So 1 by r dr by d theta, you will get a, apply product rule, a into e raised to theta plus okay, so take apply log r is equal to log a plus log e raised to theta. So log r differentiation is 1 by r dr by d theta. Then log a differentiation is 0. Then log e to the power of e theta means e get cancelled, only theta is left. So differentiation of theta with respect to theta is 1. So like that you will get r d theta by dr, reverse this one. So tan phi 1 is equal to 1. Similarly, take the second curve, r into e raised to b is equal to b, then r is b by e raised to theta. Then differentiate with respect to theta, 1 by r dr by d theta is equal to 0 minus 1, you will get. So then reverse this, r d theta by dr, this is minus 1, tan phi 2 is equal to minus 1. Now take the product, tan phi 1 into tan phi 2 is 1 into minus 1, and therefore tan phi 1 into tan phi 2 you will get minus 1. So therefore the two curves intersect orthogonally. Next, here one more problem. Find the angle between the curves r is equal to sin theta plus cos theta and r is equal to 2 sin theta. Also find the point of intersection. So here first curve is r is equal to sin theta plus cos theta. Second is r is equal to 2 sin theta. Again you have to apply log r is equal to log sin theta plus cos theta. Differentiate with respect to theta. So you will get 1 by r, log r differentiation 1 by r, then dr by d theta. Again log sin theta plus cos theta is 1 by sin theta plus cos theta. Again differentiate sin theta plus cos theta, you will get cos theta minus sin theta. Then reverse this, r into d theta by dr, then this is also reversed, cos theta plus sin theta divided by cos theta minus sin theta. So this is tan phi 1, then take cos theta common from the numerator and cos theta from the denominator. So in the numerator 1 plus tan theta, and in the denominator 1 minus tan theta is left. Or this is cos theta get cancelled, or tan phi 1 is equal to, now this 1 plus tan theta by 1 minus tan theta is same as tan of pi by 4 plus theta. Okay, or tan get cancelled, phi 1 is equal to pi by 4 theta plus, you will get. Now take the second curve, r is equal to 2 sin theta, apply log r is equal to log 2 plus log sin theta, differentiate with respect to theta, you will get 1 by r dr by d theta, which is 0, then differentiation of log sin theta is 1 by sin theta, and again applying chain rule, sin theta differentiation is cos theta. Then this gives 1 by r dr by d theta is equal to cos theta by sin theta. Now reverse this, r into d theta by dr, this is also to be reversed, sin theta by cos theta, or this is tan phi 1 and this is tan theta, tan get cancelled, phi 2 is equal to theta, you will get. So now we have to find the angle between the two curves. So alpha is absolute value of phi 1 minus phi 2, so phi 1 is pi by 4 plus theta minus phi 2 is theta, theta get cancelled, alpha is equal to pi by 4, you will get. So this is the angle between the two curves, r is equal to sin theta plus cos theta and r is equal to 2 sin theta. So this is how we find the angle of intersection of two curves, and also we show that the two curves cut orthogonally. So in each other two type problems, same techniques are applied. So here the problem is the curve, show that the curves r is equal to a into 1 plus cos theta and r is equal to b into 1 minus cos theta cut orthogonally. Same method is applied, taking log, finding tan phi 1, tan phi 2, then product, showing that product of tan phi 1 and tan phi 2 is equal to minus 1. Okay, and this is also similar, and we show at last tan phi 1 into tan phi 2 is equal to minus 1. Here what we got, tan phi 1 is 1 plus sin theta by cos theta, and tan phi 2 is equal to minus of 1 minus sin theta by cos theta. Now to find the product, tan phi 1 into tan phi 2 can be written as this into this term. Now simplify this term. Simplify this term, we will get 1 minus sin square theta. So here this is minus a plus b into a minus b, a square minus b square. So 1 minus sin square theta divided by cos square theta. So 1 minus sin square theta is cos square theta. Cos square theta get cancelled, and you will get this as minus 1. Okay. So therefore the product of tan phi 1 and tan phi 2 is equal to minus 1, and hence the two curves intersect orthogonally. Okay, so all these problems are very easy and they are very simple. So try to solve these problems. Okay, I just okay, so with this I conclude this class and continue in the next class. Thank you.